In this lesson, we're going to look at trig identities. So trig identities are statements that have been proven to be true. So a proof is proving a statement to be true. So you're not solving it per se, you're not finding an answer, you're proving that a statement is equal or is said to be true. So basically you're proving that the left side is equal to the right side. So there's a few things that we already know to be true that we can use in further proofs. So for example, we know that cosecant is equal to 1 over sine. We know that secant is equal to 1 over cosine, and we know that cotangent is equal to 1 over tan. Those have been proven to be true. Those are trig identities that we can use. We can also use tan is equal to sine over cosine, and its reciprocal cosine equals, or cotangent equals cosine over sine. So that has been proven to be true. And we have our Pythagorean theorem, trig identities, sine squared plus cos squared theta equals 1, which we could rearrange. If we wanted just sine squared, we could move the cos squared to the right. And if we wanted just cos squared, we could move the sine squared to the right. So that's sort of 3 versions of the same proof. So these are the trig identities we know to be true, and these are identities that we can use to prove further identities. And these should all be on your formula sheet that you have at the beginning of the course. So a couple of directions or suggestions for doing proofs. Number 1, form. We can't use an equal sign in between. Because we haven't proved that they are true yet. So you can't say they're equal until you have proven they are equal. So sometimes we say that we separate left side, right side, or you can use a t-chart to separate left side and right side. So we'll look at that when we do our actual proof. So form does matter. We can't say that they're equal until we've proven they're equal. So we're going to keep the left side and the right side separate. What else? We want to change everything to sine and cosine. If they're not already in sine or cosine. So that's a strategy that we can use initially. We look at both sides, and if it's not in sine or cosine, we change it using these identities we have at the top. You can work down either side. Or both. So it doesn't really matter which side you work down, but you have to work down that one side exclusively. You can't bring anything over. So cannot move terms to the other side. So you have to work exclusively down one side at a time. So you either work down the left side, or you work down the right side, or you work down both, but you can't move anything from the left side to the right side, or vice versa. Once you've changed everything to sine and cosine, so actually I'm going to put this a bit further down because this is more of a strategy than a form thing. So number 1, form, work down left side, right side. Number 2, you can work down either side exclusively, but you cannot move terms from left to right. So those are more operational things. So strategies, the first strategy I would do is change all terms to sine and or cosine. After that, we simplify. So that can involve lots of things. It can involve adding terms, subtracting terms, multiplying, dividing, factoring, expanding. All those math skills that you know, that you've learned, that's what we are going to use to simplify. Another thing that you want to look at is keep an eye on the other side. You don't want to blindly go down one side and not keep checking the other side to see what you are trying to prove to be equal. And another strategy is only replace terms for a reason. So sometimes people see a 1 and they automatically switch it to sine squared plus cos squared for no particular reason. They just know that that's equal. So you always want to have a reason for replacing terms or switching terms out. Okay, so that was one of my identities here. Here's my identities. So I know that sine squared equals 1 minus cos squared and cos squared equals 1 minus sine squared. Just have a look at a couple of examples. So in the first example, we want to prove that cosine theta times tan theta is equal to sine theta. We want to prove that this statement is true. So on the left side, we have cos theta times tan theta, and on the right side, we have sine theta. So when I look at this, on the right side, there's really not much to do. It's already in terms of sine. I can't do anything to simplify, so I'm going to work on the left side. On the left side, I can see that I have a tan theta, and my first strategy is to change everything to sine and cosine. So I'm going to change tan to sine theta over cos theta, because that's one of my trig identities. So make sure you keep these trig identities in front of you. And then I say, well, what could I do to simplify? Well, I see that there's a cosine there and a cosine there that I could reduce. So I'm reducing. So always try to reduce if you can. And that leaves me with sine theta. And now I see that the left side is now equal to the right side. So I am done with this proof. I've proved that the left side is equal to the right side. Okay, question 2. We have cotangent x. Sometimes you'll see an x, sometimes you'll see a theta. They're both the same, they're both a variable. Wrote that wrong. Cotangent over tan, and I want to prove that's equal to 1 minus sine squared x over 1 minus cos squared x. Okay, so I'm going to do it in the t-chart this time. Doesn't really matter. I'll just keep it separate. So on the left side, I have cotangent divided by tan, and on the right side, I have 1 minus sine squared over 1 minus cos squared. So on the right side, it's already in sine and cosine. I'm not really sure what I'm going to do with it yet, so I'm going to work down the left side first. So cotangent is equal to cosine over sine, and tan is equal to sine over cosine. What can I do to simplify? Well, I could take the numerator, multiply it by the reciprocal of the denominator, and then I can simplify that by multiplying. So cosine times cosine is cosine squared. Sine times sine is sine squared. So then I go to that strategy. Well, let's check the other side. Always keep an eye on the other side and see what you are trying to prove to be equal. So they don't look the same. Cos squared over sine squared on the left, 1 minus sine squared over 1 minus cos squared on the right. But what I do know is that 1 minus sine squared equals cos squared, and 1 minus cos squared equals sine squared, because so this is where we replace for a reason. The reason I'm replacing 1 minus sine squared is because I want it to equal cos squared, like the left side, and I'll replace 1 minus cos squared with sine squared. So now left side equals right side. So my strategy was change terms to sine and cosine, simplify, check the other side to see what you're trying to achieve, and replace if you have to. Keep in mind, I could have also replaced the left side. Right? I didn't have to change the right side. I have options. I could have replaced this side with 1 minus sine squared over 1 minus cos squared. Right? Could have done that too. So it doesn't really matter which side you change, as long as the left side is equal to the right side. All right, let's try another. Sine plus cosine. I'm going to put this on a different page. If I can. How do I do a new page here? well, I guess we'll just continue down. All right, number 3. Oops. So we have sine x plus cos x squared and 1 minus 2 sine x cosine x. Let's double check that is correct. Sine x, okay. So on the left side, I have sine x plus cosine x squared, and on the right side, I have 1 minus 2 sine x cos x. So the left side, I could expand. So let's do that. Everything is in terms of sine and cosine, so what can we do to simplify? Well, we could expand this. So sine times sine, we get sine x times cosine x, we get cosine x times sine x, and then we get cos x times cos x. And then I have 2 of the sine x cos x in the middle. So then I check the other side. Oh, maybe that's a plus. I think that's a plus. So I check the other side, and what I see is the same as this middle term, right? I've already got that, so that's great. What I don't have is the 1, but I do know that sine squared plus cos squared is equal to 1. So I'm going to replace sine squared plus cos squared with 1, and then I get left side equals right side. Okay, so that's another reason why I look to check, see what's the same and what's different. This should be a plus. And then I can replace. In example 4, let's do example 4. So on the left side, we have 1 over sine squared x plus 1 over cos squared x. And on the right side, we have 1 over sine squared x times cos squared x. So everything's in sine and cosine. On the right side, there's nothing really to do. So I'm going to work on the left side. I could find a common denominator. So this is how I can simplify this side by adding the terms together. So in order to add together, I need a common denominator. So I'm going to multiply the left term by cos squared x because the common denominator is cos squared x sine squared x. So the left term I'll multiply by cos squared, the right term I'll multiply by sine squared. Then I compare it to the other side. I see that the denominator is the same, so that's perfect. The numerator is not, but again I can use that trig identity, sine squared plus cos squared equals 1. And then I have left side equals right side. So finding a common denominator is a common kind of theme. It's good to practice. And then let's look at the last term. Okay, let's look at that last question. What's the last one? Tan squared minus sine squared. So left side is tan squared minus sine squared, and right side is sine squared times tan squared. Let's just double check that. Tan squared minus sine, sine times tan. Okay. So on the left side, we could change tan to sine squared theta over cos squared theta. So we want to change it to something that has sine and cosine in it. What can we do to simplify? Well, we could find a common denominator and add these terms together. So the common denominator is cos squared theta. So that will leave us with sine squared theta minus sine squared theta cos squared theta in the numerator over cos squared theta, which is the common denominator. So I'm just going to leave that for now because I'm not sure what I'm going to do with it yet till I work on this side. So on this side, I'm going to change tan to sine squared theta over cos squared theta. Sine squared times sine squared is sine to the power 4 over cos squared theta. So then I'm going to compare. So I'm going to look at the left side and say, well, the denominators are the same. Perfect. The numerators are not. On the left side, I have this cosine that I don't have on the right side. You'll see that the right side doesn't have a cosine in the numerator. So this is the reason why I would replace that. because I don't want cosine. So I'm going to change that to 1 minus sine squared. So that would be replacing something for a reason, because I don't want it there. So then I would expand brackets, so minus sine squared times sine squared. Then I have negative times a negative is a positive. Sine squared times sine squared is sine to the fourth. And then I see that this term and this term add to 0. Oops. Which leaves me with sine to the fourth over cos squared. So left side equals right side, and I am done. Okay, so my strategy, again, I changed everything to sine and cosine. I did what I could to simplify. Then I checked the other side, what looks the same, what looks different, what could I replace, and then I'm done.